This video is brought to you by Altium Designer. The DFRobot FireBeetle 2 ESP32 board has made things quite easy. If you compare it with the previous versions of ESP32 boards, you will get an idea of how advanced it is. Its use is exactly the same. All the projects that I have made using these boards can also be run on this one. You just need to pay attention to the pins because the pinout of the ESP32 FireBeetle 2 is different from the previous boards. Anyway, I will share some examples with you so that you can easily get started with this remarkable piece of hardware. The examples will include: number 1, how to control the onboard LED. Number 2, how to make an IoT-based two-way communication system using the new Blynk V2.0. We will control an LED and monitor a potentiometer as well. Number 3, we will explore live video streaming. Number 4, I will explain how to use a TFT LCD. And lastly, number 5, we will build an intermediate level temperature monitoring system using the MLX90-614 non-contact infrared temperature sensor. Guys, we have to cover a lot of things, so without any further delay, let's get started. The new ESP32 FireBeetle 2 is based on the ESP32 S3 WROOM-1 generic Wi-Fi plus Bluetooth low energy microcontroller module that is built around the ESP32 S3 series of SoCs. The board has Type-C USB port. This is the onboard LED. If you long press this button for 6 seconds, it will power off the board, and if you press it for 2 seconds, it will power on the board. This is the reset button. This one is the boot button. This board has the ESP32 power management chip and the ETA6003 lithium-ion battery charging management chip. This is the lithium-ion battery port. This is the charging indicator LED. If this LED is off, it means either the power supply is not plugged in or battery is fully charged. And if this LED is on, then it means the battery is charging. And if this LED is blinking, then it means the battery is not connected. This is the GDI graphics device interface, and this is the DVP digital video port camera interface. Key specification are: you can follow this pinout diagram, and I think there is no need to waste time by explaining all these pins because all the pins are clearly labeled. But still, if you want to study about these pins and different interfaces, then you can read my article available on electronicclinic.com. I will add a link in the description. Now let's start with our first example, that is blinking the onboard LED that is connected to the digital pin 13, just like the Arduino. Anyway, to control the onboard LED for this, first of all, we will need to add the ESP32 FireBeetle 2 in the Arduino IDE. Because by default no ESP32 board is installed in the Arduino IDE, and you can confirm this by going to the tools menu, then to board, and you can see there is no ESP32 board. So first we will need to add it in the boards list. For this, go to my website and copy this board manager URL link. Then go back to the Arduino IDE, go to the File menu, then Preferences, and paste this link in the additional boards manager URLs. Next, go to the Tools menu, then Board, and click on the Boards Manager. Search for the ESP32. You can see we have Arduino ESP32 boards and ESP32 by Espressif Systems. So make sure you install this one and don't forget to select the latest version. Finally, the board installation has been completed, and now we can confirm this by going to the boards list. You can see all the different variants of the ESP32 boards have been added. So let's scroll down and check if we can find the DFRobot FireBeetle ESP32 S3 board. Here it is. So we are done with the difficult part, and now let's open the LED blinking program. This is the same exact program used to control the Arduino Uno or Arduino Nano onboard LED. The purpose of this program is to turn on and turn off the onboard LED. If you are new to the Arduino IDE, then I highly recommend watch my 1-hour video on the Arduino course. Anyway, to upload the program, make sure your ESP32 FireBeetle 2 board is connected to your laptop or PC. Go to the Tools menu and select the DFRobot FireBeetle 2 ESP32 S3 board. Make sure you enable the USB CDC on boot. Set the flash size to 16 MB 128 MB. Set the partition scheme to 16 MB flash 3 MB. Set the PSRAM to OPI PSRAM, and finally select the port, and then you can upload the program. The program has been successfully uploaded. Now you can see the onboard LED is blinking exactly the same way you can control any I/O pin. Now in this next example, we are going to control this LED and monitor this potentiometer using the new Blynk V2.0. First, let me explain the connections. The rightmost and leftmost legs of the potentiometer are connected to the FireBeetle board pins 3.3 volt and ground, whereas the middle leg of the potentiometer is connected to the analog pin A0. Cathode leg of the LED is connected to the ground pin, and the anode leg of the LED is connected to the digital pin D12 through this 330 ohm current limiting resistor. 330 ohm resistor I usually use when I use 5 volts compatible controller boards like Arduino, but since this is a 3.3 volt compatible controller board, so technically you will need a resistor of 40 ohms, but to be on the safe side you can use a resistor of 100 ohms. But right now I have a 330 ohm resistor, and that's why I used it, and I know it's going to reduce the LED brightness. Anyway, you can follow this circuit diagram. Now before we start setting up the Blynk Cloud dashboard or the Blynk IoT app for controlling the LED and for monitoring the potentiometer, first we will need to install the Blynk library in the Arduino IDE, so let's do it. While the Arduino IDE is open, go to the sketch menu, then to include library and click on the manage libraries. Search for the Blynk. And make sure you install the Blynk by this guy, and don't forget to select the latest version. Anyway, you can see I have already installed it. So once you are done with the Blynk library installation, then you can start working on the Blynk Cloud dashboard. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for the delay, push, slide, and walk around faster than ever. Easily work together with your mechanical team and forget about the days of swapping design files. Every design change stays in sync between Altium Designer and SolidWorks, PTC Crew, Autodesk Inventor, Autodesk Fusion 360 or Siemens NX. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. One of the best things about Altium Designer is that you can share your designs with your team members using Altium 365. They can check your design, leave comments, and if there are any issues, they can fix them from anywhere in the world. Altium Designer also uses the world's fastest component search engine, Octopart, so you won't have any difficulty in searching for components. Links to the Altium Designer, Altium 365, and Octopart are given in the description. I already have a getting started video on the new Blynk V2.0 and ESP32 Wi-Fi plus Bluetooth module. So for the step-by-step explanation, you can follow that video. I have added a link in the description. In that video, I have used the same LED and potentiometer. Once your dashboard is ready, copy these credentials and paste it in the programming. You can download this program from our website electronicclinic.com. Finally, you can upload the program. You can see the program has been uploaded. Next, restart your ESP32 FireBeetle board and make sure your laptop and FireBeetle boards are connected to the Wi-Fi. Go back to your Blynk Web dashboard and check if the value on the gauge updates as you rotate the knob of the potentiometer. On my side, it's working. Now let's set up the Blynk IoT app on the cell phone. Blynk IoT app setup I have already explained in the new Blynk V2.0 getting started tutorial. So I highly recommend you guys should watch that video because in that video I have explained a lot of other things. Anyway, for now, just follow the same exact steps, and if in case you face any issues, then you can watch that video. Now I can use this app to control the LED and for monitoring the potentiometer. You can replace this LED with a relay to control high voltage and high ampere AC or DC loads, and the same thing applies to the potentiometer. You can replace it with any other analog or digital sensor. The Blynk Web dashboard and the Blynk IoT app setup will remain exactly the same. For the better understanding, you can go ahead and watch my other videos on the new Blynk V2.0. Now let's go ahead and start with the camera. The camera interface is compatible with both OV2640 and OV7725 cameras. Enable ESP32 power output when using a camera. This is the pin list for using the DVP camera interface. This is the OV2640 camera module that I'm going to use with the FireBeetle 2 ESP32 S3 board. On the back side of the FPC flexible printed cable, you can see the pin numbering starts from the right side, and on the FireBeetle board you can see this white dot next to the camera port, which indicates that this is the pin number 1. So while connecting the camera, make sure pin number 1 on the FPC is towards the dot side. So the camera is connected, and next we are going to add library in the Arduino IDE. So while your Arduino IDE is open, go to the sketch menu, then to include library, and click on the add.zip library. Browse to the location and select this library. You can download this library from the article available on electronicclinic.com. You can see I have already added this library. This is the program that you will need for the live video streaming. You can download this code and all these other files from our website electronicclinic.com. I have added a link in the description. Anyway, when you have this code opened up in your Arduino IDE, scroll down and make sure you change these Wi-Fi credentials. Before you upload the program, make sure you select the correct version of the FireBeetle board, that is DFRobot FireBeetle 2 ESP32 S3. And make sure these values on your side matches with mine. I already explained it in the LED blinking example. So if you have skipped that part, then I highly recommend you should watch that part of the video, because these settings are necessary before you upload the program. Finally, select the communication port and then you can click on the upload button. After uploading the program, unplug your ESP32 FireBeetle board and plug it again. Then open the serial monitor. Copy this URL link and paste it into the web browser. You should be able to see these settings, so simply scroll down and click the Start Stream button. The live video streaming will start in no time. Now you can play around with these different parameters. You can also do live video streaming on your cell phone. Next, we are going to use this 320 by 240 IPS TFT LCD display with the FireBeetle 2 ESP32 S3. It supports SPI 4-wire communication mode and GDI port. It accepts a wide range of input voltages from 3.3 volt to 5 volt, which makes it compatible with multiple main controller boards like Arduino, Leonardo, ESP32, ESP8266, and so on. Use the GDI interface on the controller board, which could effectively reduce the wiring, and if you plan to use it with the Arduino or any other controller board that doesn't come with a GDI interface, then you can use these male headers. Since the FireBeetle 2 ESP32 S3 board already has a GDI port, so I'm going to use the FPC cable. There is also an onboard micro SD card slot for storing and displaying images. So this module has the advantage of high resolution, wide viewing angle, and simple wiring, and can be used in many display applications: waveform monitor display, electronic gift box, sensors monitoring, electronic weather decorations, and so on. Anyway, the LCD is connected, and next we are going to add library in the Arduino IDE. So while your Arduino IDE is open, go to the sketch menu, then to include library, and click on the add.zip library. Browse to the location and select this library. You can download this library from the article available on electronicclinic.com and click the open button. You can see I have already added this library. You can use this program to check your TFT LCD. Before you upload the program, make sure you select the correct version of the FireBeetle board, that is DFRobot FireBeetle 2 ESP32 S3, and make sure these values on your side matches with mine. I already explained it in the LED blinking example. Finally, select the communication port and you can click on the upload button. The TFT LCD is working, and now let's work on the temperature monitoring system using the MLX9614 non-contact infrared temperature sensor. Connect the VCC and ground of the MLX9614 non-contact infrared temperature sensor to the 3.3 volt and ground pins. Connect the SDA and SCL pins to the SDA and SCL on the FireBeetle 2 ESP32 board. You can follow this circuit diagram. And now let's go ahead and take a look at the programming. You will also need to install the DFRobot MLX9614 library. For this, go to the sketch menu. Then to include library and click on the manage libraries. Paste the library name in the search box. You can see I have already installed this library. The program is a bit longer because we are displaying the temperature values on the gauges. If you don't use gauges, the program will become quite small. These are the pin definitions for various controller boards. These are the different display modules. Simply uncomment the one you are using. In my case, I have uncommented this line. Next, I have defined some colors and variables. All these instructions are used with the TFT display module to enable the display. Set the orientation, fill the screen, set the text color, set the text size, and so on. Next, we select the desired emissivity correction coefficient. 0.91 is for the human skin. Every object has its own emissivity value. I've explained this in my getting started tutorial on the MLX9614 temperature sensor. I've added a link in the description. In the loop function, all these instructions are used to display the temperature values on the gauges. I have already uploaded this program, and now let's watch the FireBeetle 2 ESP32 based temperature monitoring system in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.